Okay, welcome to your first video for pre-calculus. This is going to go fairly quickly. I think we'll be able to get all this done in one 15-minute video. We're going to continue with the fundamentals that we began in class. We're going to talk tonight or today about exponents and radicals. First, integer exponents. I'm going to go through this really quickly because you know this already. This is not new information to you. This is just a review so that you can come to class next time and be ready to do homework. Don't know what that was, but I'm going to keep going. So if we have exponents that are integers, we have any base number, we're calling it a here, which is any real number, and we're raising it to a power of n. And exponential notation is just shorthand for multiplication. How many times am I multiplying this base number a times itself? That's all exponents are. Exponents can be any real number. We're talking now about n being a positive integer, but it can be any real number. It can be 0, it can be a negative integer, it can be a fraction, all of those things. Remember that any base number, any real number, a, pi, 3, 15, e, whatever the base number is, raised to a power of 0, has a value of 1. And when we have a negative integer, remember we cross the fraction line and we change the sign on the exponent. So if it's in the numerator and it's a negative exponent, we can move it to the denominator of a fraction and it becomes the same value. It's just a positive exponent. So let's talk about rules for working with exponents. You know all of these rules. When you're multiplying the same base, but they're raised to a different power, you add the exponents. When you have a ratio or a fraction of the same base raised to different powers, it's the power or the exponent in the numerator minus the power or the exponent in the denominator. When you raise a power to a power, you multiply those exponents. When you have two different bases, two different real numbers you're multiplying together, and that quantity is raised to an exponential value, exponents break up over the multiplication sign. So that number outside the parentheses is an exponent on every single variable that is in that parentheses. And just like exponentiation breaks up over multiplication, it also breaks up over division, and that's what all of those rules mean. Same is true for negative exponents, breaks up over multiplication, breaks up over division, so that's not new information to us. The beauty part about radicals is radicals can be done by changing them into exponents. If we have the nth root of the real number a, that can be rewritten as a to the 1 over n power. So all we really need is exponential rules. We don't really need properties of nth roots because we can change all of those to exponentials and we can use our exponential rules. So rational exponents, that's what we've been talking about. If we have the nth root of a all raised to the m power, that is equivalent to a raised to the power of m over n. M is the exponent that applies to the base number a. N is the root. So when we realize that, we really don't have a whole lot of rules that we need to know. Now, very quickly, rationalizing the denominator, understand that this 1 over the square root of any real number, as long as it's a real number, I didn't say complex number, any real number is a perfectly fine way to show your answers. We don't, as we go higher into mathematics, we don't really worry that much about rationalizing the denominator. That's something that's done fairly often in lower mathematics, and I'm only including it here because you definitely could see it on your ACT. But as far as us for pre-calculus and calculus, unless it's a multiple choice question, you know, that I've had generated from some software that rationalizes everything, you're going to be able to give your answer like this and it's not going to hurt anything at all. But we can just multiply by a power of 1, which is all we're doing when we're rationalizing the denominator. We can multiply anything by 1 and get that one thing back. Same value, it just looks different. So we're just multiplying by a well-chosen 1 that gets rid of the root in this case a square root, in the denominator. So we did that very quickly. I didn't work any examples. I don't think you need me to work any examples. Come to class next time, we'll work some homework, and we'll go from there.